Um, Today, this morning, we're mostly going to be going over kind of an update of what's been going on with Autoware. Those of you who aren't familiar, the Autoware Foundation is a nonprofit organization that is founded in Japan and is around to kind of steward the Autoware projects, which include Autoware.auto, Autoware AI, and Autoware.io. And they're essentially there to provide an open source stack of software for self-driving vehicles. So today we're going to kind of go over what has changed in Autoware.auto since the last time we did a Silicon Valley meetup, which was probably 7-8 months ago. And we'll go over things that have been updated and what new projects we're working on in the foundation. And some of that applies to F110th, which kind of overlaps a little bit with DIY robocars that's coming up this weekend. So we'll talk about how those things collide. So I'm Josh Whitley. I'm currently the software architect for the Autoware Foundation. I am also the owner and founder of Whitley Software Services. I do contracting. The job I do with the foundation is a full-time contract as the software architect. And I'm actually transitioning out of that role to a full-time job with a company called Gaia, based here in the Valley. And they do also software for autonomous platforms, but a little more generic than what Autoware does. So what exactly is Autoware.auto? So Autoware.auto is based on ROS2 and DES. For those of you who haven't heard of it before, ROS is the robot operating system, and it's a set of packages and an ecosystem for building applications on robots. And DES is just a message passing architecture that we can talk about in more detail during the hackathon later this afternoon. Autoware.auto is an open source autonomous vehicle stack. And the way we do our development in the Autoware Foundation is we target operational design domains. And essentially what that means is a set of operating conditions in which you want to have a specific task accomplished. So we target ODDs and develop specifically all the features that are necessary to run an autonomous vehicle within that ODD. Autoware.auto also provides a modular reference design, and hopefully with clearly defined APIs. And the reason that the APIs are so important to us is because the Autoware Foundation has a lot of members that are commercial entities and corporations, and we want to make it easy for them to implement the parts of Autoware.auto that they want from the open source version, and then do their own thing in the rest of the autonomous stack. And so we try to clearly define our APIs so they have an easy way to connect their portions of the software with the open source portions of the software. So you can find the usage and API documentation on this website, autowarefoundation.gitlab.io, and I'll provide the slides later so you can click that link if you want to look at the docs. We try to provide design documentation for everything that's in Autoware.auto, as well as usage documentation for demonstrations and different portions of the stack and whatnot. But if you ever find anything missing in the docs, feel free to open an issue on our GitLab, and we'll try and clean that up as much as possible. So Autoware.auto is kind of a new iteration on Autoware.ai. So you saw at the beginning, this is based on ROS2. We had an initial implementation that was based on ROS1, and that was called Autoware AI. Autoware AI was developed originally as a PhD project and continued to be developed by PhD students. So it kind of grew organically and was not well organized as a large autonomous stack from the beginning. So when we developed Autoware.auto, we intentionally developed it with safety, code quality, static memory allocation, modularity, and documentation in mind. So we attempted to architect that as best we could from the beginning with all of those things, and we continue to expand those as we grow. So every time a merge request is made to Autoware.auto, we require that you have a certain number of linters and static analyzers run on it, that you have unit tests for at least all of your code. We don't require 100% unit test coverage on all of the code you write, otherwise our unit tests would be 20 times as big as our code base. But we at least want to make sure that when you add code, the coverage value does not go down from what it already is. And then we have a website at Autoware.auto, which this now redirects to Autoware.org. So all of our information about all the projects that we do is on Autoware.org. But you can also go to Autoware.auto and just redirect. And then the actual repository where we host all of the code is on GitLab. So you can go to gitlab.com/AutowareFoundation/Autoware.auto/AutoWare.auto, or if you just Google Autoware.auto, it's probably the first thing you'll find. So a little bit of history about Autoware.auto. Development first began in August 2018. The initial framework for Autoware.auto and development was done by a member company of the foundation at the time named Apex AI. They're another company here in the Valley, and they developed a hardened version of ROS2 that is API compatible with ROS2. So if you wanted to run anything from Autoware.auto on like a hardened safety rated version of ROS2, they offer a product for that. And they were contracted by Tier 4, which is the company that founded, one of the companies that founded the Autoware Foundation, to develop the first version of Autoware.auto. And the first release was made in August of 2019. So that first release just included a very small subset of functionality and the basic framework, so that we had something to build on top of. Our first full release was the 1.0 release in February of 2021. And that release targeted a specific operational design domain, which was autonomous valet parking. So we had all the functionality you needed in there to be able to get out of a vehicle and press a button on your cell phone, which would cause the vehicle to go park in a parking spot. And then you could come back out of the building, press another button, and the vehicle would come out of the parking spot, drive up to you, and let you into the vehicle. We did do this with a safety driver because we were not attempting to do level 4, level 5 autonomy, but the functionality for what needed to be done was there, just with oversight from a safety person. And then the development of Autoware.auto is overseen by the Autoware Software Working Group. And we have a number of working groups within the foundation. If you go to our website, there's a meeting calendar there, and they are all open to the community. So if anyone's interested in joining, we have a software working group, a hardware working group, a simulation working group, a racing working group, and a whole bunch of others that might hit your interests. So Autoware.auto right now currently targets ROS2 Foxy, which is the most recent long-term release of ROS. We will be adding support for ROS Galactic, which is the current short-term release, very soon, hopefully within the next month or so. We also provide a Docker-based development environment and also a runtime environment called ADE. And ADE is, if you've ever used Docker, it's similar to Docker Compose. It allows you to run multiple Docker containers and attach volumes to them and so on. And it allows you to do that with just a single command. So it's an easy interface to get complex Docker environments up and running. And then we natively support AMD 64 and ARM 64 environments. We are working on NVIDIA Jetson support. And if any of you are sticking around for the hackathon this afternoon, I just finished getting Jetson support up and working, where we have a Docker environment that can access the Jetson hardware and also runs Autoware.auto. So as far as the feature set that's included in Autoware.auto, the primary focus of Autoware.auto is to be a framework with a set of common APIs, but we need to provide functionality on top of that, obviously, so that you can do some stuff with it when you first download it. So within that, on the sensing side, we offer the ability to run with any GNSS system, which has a ROS2 driver that produces a very common message structure called navsatfix. Any LiDAR that has a ROS2 driver that produces a point cloud 2 message type, which again is a very common message type within the ROS community to represent LiDAR point clouds. We're currently working on the development of a radar-based pipeline, and that we have a driver for a couple of radars. Surprisingly, it's actually very hard to get a hold of the APIs to talk to radars because most of the radar manufacturers are vehicle OEMs and they don't really want that kind of stuff being public. So making open source drivers for those is much harder than you think. But we actually did get cooperation from a radar manufacturer called Smart Micro. They've given us their API and allowed us to make it public. And so we've written a driver for the Smart Micro radars, and we will be adding some radar processing functionality into Autoware.auto in the coming months. The camera pipeline is under development. There are a lot of community resources in ROS2 for camera pipelines. So we're kind of leaning on the ROS2 community for the data acquisition from the cameras, doing things like distortion correction and the kind of things you would want for the images before they go into like a machine learning algorithm for classification or something like that. So we are adding support for being able to take regions of interest from a camera frame and then feed them into a data fusion algorithm. And that's almost complete. And so when that's done, we'll be able to fuse at least LiDAR and camera inputs into semantic representations of the object data. As far as localization goes, we currently support LiDAR-based NDT matching, which is basically a nearest neighbor algorithm to look at a predefined point cloud map and then look at the scan data from your LiDAR and say, where within this huge point cloud am I currently located based on the active scan? And then we also support GNSS-based positioning. So if you have GPS data giving you latitude, longitude, that'll get turned into XY coordinates, and then you can use our state estimator with multi-input fusion to fuse together the GNSS data and the NDT output. As far as perception on the LiDAR side, we have LiDAR-based ground filtering using array classifier. We also have object detection using Euclidean clustering. We are, I would say, 95% or so done with our object tracker. So we're able to take the clusters that are developed by the LiDAR Euclidean clustering and then add in the object classification data from the cameras and create tracks out of that so that we can get things like velocity data and acceleration and good bounding boxes for the objects and that sort of stuff. So the tracker is nearly complete as far as those two inputs are concerned. And then we're adding more inputs from the radar and so on so that we can get better tracks. As far as what vehicles we currently support, we consider vehicle interface to be a little bit of a generic term. So that covers drive-by-wire systems, software packages which connect directly to drive-by-wire systems, and simulators. So we currently support the Autonomous Stuff SSC software kit, which is a closed source set of software for vehicle control. Anything that is produced by, or anything that has the drive-by-wire system from the New Eagle Raptor. New Eagle is the company, Raptor is the product, and they have a very standardized CAN interface to all of the vehicles that they support. So things like the Chrysler Pacifica, the Ford F-150, the Ford Fusion, Lincoln MKZ, all of those are supported by the New Eagle drive-by-wire system. So any of those vehicles can be controlled by Autoware.auto without modification. We also have a joystick vehicle interface so that you can just drive the vehicle around with a joystick. That applies to any of the other vehicle interfaces as well. It's kind of a layer on top of them. And then we support the SVL simulator from LG. We are looking into support for other simulators. There's one called Project Chrono, which is a very, very detailed physics simulator that was used for simulating the tread slip on the Ingenuity rover that went to Mars. So it's not meant as like a real-time simulator for large-scale environments. It's meant specifically for small physics simulations. But we're working with them to provide an interface from Autoware.auto as well. And then in any autonomous stack, you've got to be able to do motion control. So we have a latitudinal and longitudinal MPC-based controller, which is model predictive control. And then we also have a pure pursuit version of that controller as well. And then we are in the process of importing from Tier 4, one of the member companies. They have their own like reference architecture and are giving us their individual latitude and longitude controllers in several different formats. So we'll have a large number of options available for how you want to control your vehicle before it gets to the vehicle interface. As I mentioned before with the NDT matching, you start with a point cloud in that case. We also support HD maps, which in this case means semantic maps. So information like the road lines, the speed limits, construction zones, that sort of stuff. And we support that in a format called lanelet. Yeah, sure. So for those on the stream, the question was for the New Eagle Raptor, how do we interface with the specific vehicles that I mentioned? So New Eagle is a provider of drive-by-wire systems.